1.2 Quadratic Functions. Within this section, we are going to end up going over many of the different topics that we have already covered within 1.1. We're going to be using and implementing all of those same processes while taking a look at different equations like the Vertex and Intercept equations that we were looking at on the last slide of 1.1. If you're not sure with those slides, I would highly suggest go back to 1.1, rewatch the video, and view that last slide to have a better understanding of what it looks like and how to work with it. We are going to go a little bit deeper into each one of them within this one video. So we're going to begin with vertex form. It's shown as y is equal to a parentheses x minus h squared plus k. Now, there is one condition for a in this example, or in this equation, and that is that a will never equal 0. Another thing is that our vertex is going to come off of the h and k. This is something that we mentioned within 1.1 as well, but just letting you know in case you did not spot that information in 1.1. We are going to start talking about transformations. A transformation is basically whenever you have a graph, the regular version or the parent function of a graph is what it would look like in its natural being, in the parent form. A transformation would be if it moved left, right, up, down, or if the parabola opened up further, or it became more narrow. That would be considered a transformation. Now, here we're going to go over vertex form and how each one of the letters within that equation go in relation with a transformation that does occur. So let's start off with A. Letter A is going to tell us whether it opens up or down based off of whether it is positive or negative. So if A is positive, it would go up. If A is negative, our parabola is going to face down. We've already gone over the fact that our vertex is going to be at the point of h and k. Notice our equation here is x minus h. One of the easiest ways to work with this equation is to think opposite and same. When I say opposite, it is in relation to the h, and k would be the same. What does that mean? Whenever we look at x minus h, many students get confused as far as, oh, minus h. So let me move towards the negative. And that we're going to do the opposite of that. We're going to see a number, let's say if it said x minus 5, we're going to take a look at the negative 5 and do the opposite of it. In this case, opposite of negative 5 is equal to 5. So we're going to move right 5 steps. And that is our h. Our h, sorry, not right. Our h is going to shift. No, it's fine. H will push us either left or right. In this case, because we are going a positive 5, we are going to move to the right, since we have x minus 5. So in this case, h would shift left and right based off of the number of h. If the equation itself shows a negative number, meaning x minus 3, we would go positive 3. If x said x plus 5, we would then go negative 5, and we would move left 5 times. When we're looking at k, k will always be the same. So if it says plus 3, we're going to move positive 3. If it says minus 3, we're going to move down 3. So we're going to do exactly what that sign tells us, and that's why we say it stays the same. This would be our up and down. Our A is also very important because not only does it tell us whether it's going to face up or down, it is also based off of whether the number that it is giving is between 0 to 1 or greater than 1. So, if A is greater than 1, it is a vertical stretch. A vertical stretch means that it is going to get taller or more narrow. An easy way to think of this is kind of like Play-Doh. As you stretch the Play-Doh and you pull up and down, what happens? We are stretching it and it becomes much thinner, much more narrow. That is a vertical stretch. If you were thinking of a vertical compression, if we were to put that Play-Doh on a table and slam our hand on the top of that Play-Doh, what would happen with that vertical compression? It would go out flatter and more to the left and right, more towards the outside. That would be a vertical compression. And that's going to happen between all numbers of 0 up to 1. So, from 0 to 1 would be a vertical compression. Any number greater than 1, we'll say 1 plus, would be a vertical stretch. And if we just end up with a 1, because notice we have a vertical compression that leads up to 1, it doesn't include the 1. How do we know it doesn't include it? Notice the signs that we're using. It does not have a line underneath it, right? So vertical compression leading up to 1, if we're larger than 1, vertical stretch. If we are just at 1, there is not a transformation. And we would just write none. Either way, please keep in mind, remember, the axis of symmetry, what we were talking about before, from that vertex is always going to be the H, right? Our H is our X. That vertical line is our X. Let's go ahead to slide 4. So when we're graphing a function from its equation, reflections, stretches, and compressions must be done before the horizontal and vertical shifts. It must be done before any type of vertical or horizontal shifts. So we need to figure out what it's going to look like first before left, right, up, or down. Slide 5. This is a quick reminder on how to figure out our intercepts. So if we are finding a certain intercept, let's say it's x, remember, the y would be equal to 0. And if we're finding the y-intercept, the x would be equal to 0. So in this case, y is equal to 0. And if we're finding the y-intercept, x is equal to 0. Let's go ahead and take a look at slide 6. Here we have a slide with various equations and what the effects would be for A, H, and K. So before we do anything else, let's go over what those different letters mean just one more time. Remember, our A is either going to tell us if it's positive or negative, meaning if it's facing up or down. It's also going to tell us if it's a vertical compression, a vertical stretch, or none. Our effect for H is going to be if it's moving left or right. And remember, that's always the opposite. Our K is going to go up and down, and that's always going to be the same. We have to be able to understand each one of these equations and see exactly what it is and what part of the equation we are looking at. So let's start off with our first equation. Our first equation, notice in this case, even though it says x squared, what this is really telling us, and I'll put the equation in view, is that y is equal to, do we have an a within that equation? The a is a 1. How do we know that? Because there's not a number that is there. That is our leading coefficient. Now, when we see x squared, keep in mind, is there anything being shown here? This would be x minus 0 squared. So when we subtract x minus 0, what are we left with? X, and then we would have it squared. Do we have a k on the outside? No, we don't. So this would also mean that our k is outside. This tells us our vertex is starting at 0, 0. What's the effect of the A? Well, there is no negative in front, which means it's going to be positive. It doesn't move as far as a vertical compression or a vertical stretch, which means there is not going to be a transformation on A. When we look at H, notice there is no H, so there is no movement left and right. And for K, there is no number there, which means there is none. If we go to the next one, x minus 1 squared. Notice now we have an H. So our vertex here, keep in mind, do we have a K? No, we don't. Our vertex would actually be 1, 0. Let's take a look at our A. In this case, do we have a number in front? No, we don't. There is no transformations. Now, since we do have a number on the inside of the parentheses, that means that there is going to be a shift. Remember, we do the opposite for H. We see x minus 1, which means it's going to be a positive 1. And since it's a positive 1, we are going to shift to the right 1 unit. When we write out our transformations, this is exactly how you should be writing your transformations. You are writing them out. You are not showing abbreviations. You are not using symbolism. You're not showing an arrow to the right-hand side, to the left-hand side. You are writing these out. So please be sure that you're using the right terminology for each one of these. Notice there is no K, so we would put none for the effect on K. Let's take a look at the third one. Here we see we have A, H, and K within our problem. So, once we are taking a look at this problem, we're going to go ahead and look at our y. Now, our equation starts off with y is equal to 3 times x plus 2 squared minus 8. We know our a, which is 3, is positive, so it's going to face upwards. Let's talk about the transformations. Since 3 is larger than, since 3 is larger than 1, at that point, we know that it's going to be a vertical stretch, and that's going to be at a factor of 3. We move to h. We do the opposite of a +2, which is a -2, which means we're going to move left 2 units. Now, why is it that I'm saying -2, but we're saying shift left 2 units? Giving the direction of left and right will tell us whether we're going towards a negative number or a positive number. It's much easier to think of a number line oftentimes and starting off at 0. Let's go ahead and take a look at k. K is a -8, which means we would be moving downward 8 units. Let's take a look at y. Now here, we are running into our first -a. Now this is going to cause instead of our parabola facing up, it's actually going to face down. When we talk about it facing down in reference to its original position, we're going to say that there is a reflection over the x-axis, or you can say that it reflects horizontally over the x-axis. Notice we do not have an h, it does not move left and right. We do not have a k, it does not move up and down. Let's take a look at the next one. Here we have -x² plus 4. Keep in mind, anytime that we have a square, that square tells us what h is. In this case, h is not there, so we do not have a movement left and right. We have a negative in front, which means it's a reflection over the x-axis. From there, our 4 is on the outside, which means this is our k. We're moving up 4 units. Let's do the last example. We have a -3. So here we have 4 different transformations that are going on. First, it's a negative, which means it's going to reflect. It's a horizontal reflection of the x-axis. It is a 3, which means that it's going to be a vertical stretch, and we're going to say it's a vertical stretch by a factor of that 3. We move on to h. Notice it says x minus 2, so we're going to be shifting right 2 units because we're going to go towards the +2, and +6 is on the outside, which means we are moving up 6 units. Slide 8. Now, at the very top of our page, it says parent function. This is what we were speaking of before. This is when we have a regular parabola, what would it look like? Our equation would actually be y is equal to x squared. Now in this case, we're going to take a look at our transformations. What transformations do we have? A is positive. A is a 1, so in this case, there are no transformations for A. We have x squared, which means h is not there, or it's a 0, so there's no movement left or right. And we do not have a plus some form of number on the outside of the square, which means it does not go up or down. So here, we're going to write none. We do not leave it blank. We always write down, if there's nothing that moves, nothing that goes in any type of direction, we go ahead and we just write none. Let's go ahead and take a look at the vertex. Do we know the vertex? Well, remember, this is the same as y is equal to a, or we can just go ahead and write 1 times x minus h. Since we don't have an h, it's a 0 squared plus 0. That means our vertex is going to be 0, 0. Our axis of symmetry is x equals 0. Is it going to be a minimum or is it going to be a maximum? Well, this is kind of important to know because notice, if it's a positive parabola, it's a positive a, we would automatically have a minimum. Well, let's start putting down the information that we know. We know our vertex is at 0, 0. We need points on the left and right side of this parabola. So we're going to go ahead, create a quick table. Now, let's plug in a number. Let's start off with a 1. 1 squared is 1. If we plugged in 2, it would be 4. Keep in mind, we are plugging the x value into our original equation. So that would give us 1, 1 and 2, 4. Keep in mind, our axis of symmetry is that middle line, and it creates a reflection onto the other side. So our other points for the left side would just be a reflection of those points. We go ahead, connect our dots, and draw our arrows at the top. Now that you have a visual representation, you can actually see how this would be a minimum, not a maximum. Our x-intercept, in this case, would be where it hits the x-axis. In this case, it would be 0, 0. We check for a y-intercept. In this case, it's also our y-intercept. Our increasing and decreasing, remember, we always have to read these from left to right. So, from left to right, notice it is decreasing and then increasing. So we would write this as it decreasing from negative infinity up to 0. And remember, we are not going to include the 0, so it's going to be a parentheses. And from 0 to positive infinity would be our increasing. Our domain is talking about our x. Keep in mind, for every parabola, it's always going to be from negative infinity to positive infinity. Our range, we are taking a look at our y-axis, right? Our lowest point would be 0. Our highest point would be infinity. Keep in mind, you are able to use brackets for the range. Lastly, end behavior. As x approaches infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches positive infinity. Let's go ahead and take a look at slide 9. Slide 9 is very similar to slide 8. It gives you a new equation for you to work on. Highly suggest try this one out and go from that point. Now, in this equation, we have a couple different things that it is already telling us in advance that we should know. First thing, we see a negative in front, which means this parabola is going to face downward. The number itself, the 2, is greater than 1, which means this is going to be a vertical stretch. We have x squared, which means there is no shift left and right. And we have a -1 on the outside, which means we are going to move down by 1 unit. What is our parent function? We're still talking about parabolas, right? So we're going to go ahead and write y is equal to x squared. Well, we just did all of the transformations, right? The first one would be a horizontal reflection of the x-axis. That's our negative. It is a vertical stretch by a factor of 2. And we are moving, and it is a shift down by 1 unit. We go ahead, head into our vertex. Our vertex in this case, keep in mind, h is not there. That means 0, -1. Axis of symmetry is on the 0. Remember, it's facing down, which means it's going to be a maximum. We need to go ahead and figure our x-intercept. So, let's start off with this. We know that our vertex is going to be at 0, -1. And we know that this parabola is going to face downward. That means, even with us loosely drawing this parabola, we already know we're not going to have an x-intercept. Well, how do we know that? Well, it's not crossing that x-axis at all. The vertex, or our maximum, is at 0, -1. It's not going to have a chance to cross over or even touch that line. We still need to be able to figure out our y-intercept. Well, since our vertex is at 0, -1, that is going to be our y-intercept. Keep in mind, from left to right, we are increasing, and we are decreasing from 0 to infinity. So we go ahead, start off with our increasing, in this case, from -infinity up to 0, and from 0 to positive infinity. Keep in mind, increasing, decreasing is always parentheses. Our domain, we're talking about x. This will always be from negative infinity to positive infinity, as long as we're talking about a parabola. Our range, well, remember, we go from the least to the greatest number. So the least number would be negative infinity, and it's going to go all the way up to -1. Keep in mind, we have a bracket on that -1. We're going to go ahead and write out our end behavior. As x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. Let's go ahead to slide 10. Slide 10 is identical to the previous problems that we've been working on. One of the more difficult areas within this problem is the finding of the y-intercept and the x-intercept for this specific problem. We'll run through the entire problem from beginning to end. Just keep in mind, we'll eventually get to that y-intercept, x-intercept, and we'll go further into details there. Our parent function here is y is equal to x squared. Our transformation, reflection over the x axis, vertical compression, by a factor of 1/2. We have a shift right 3 units and shift up 4 units. Our vertex here would be 3, 4. Axis of symmetry is 3. We would have a maximum, since we have a -1/2. I'm going to go ahead, I'm going to skip the x-intercept and y-intercept for now and kind of hop into our other answers first, because it's much easier to solve those than the x and y-intercept just yet. So, increasing, if it is facing downward, we have a vertex of 3, 4. So we go 3, up 4. Since it's facing downward, and we're going to say a rough drawing, we can see that it's going to increase from -infinity up to 3, and from 3 to positive infinity, it is going to decrease. Our domain, once again, is always -infinity to positive infinity. Our range is going up to the 4 from -infinity. So -infinity is our lowest number. Up to 4, we put a bracket around the 4. End behavior would be, as x approaches infinity, f of x approaches -infinity. As x approaches -infinity, f of x approaches -infinity. Now let's solve these last 2 answers that we have. In this case, what ends up happening is solving for our y-intercept. Remember, we are going to plug in 0 for x. So when we do that, this is going to be for the y-intercept. We're going to get negative 1/2 0 minus 3 squared plus 4, and we'll just work that out. Negative 1/2 negative 3 squared plus 4, negative 1/2 times 9 plus 4. We end up with negative 9 over 2 plus 4. Now we can turn this into a fraction, which we have, or we can turn this into a decimal. Either way is perfectly fine. This would be the same as saying negative 4.5 plus 4 is equal to negative 0.5, and we turn this into our point of 0, negative 0.5. And that right there is going to be our y-intercept. Let's go ahead and take a look at our x-intercept. In that case, remember, that is where 0 is equal to 1/2 x minus 3 squared plus 4. And we're going to go ahead and solve for x. We're going to bring over the 4. So negative 4 is equal to 1/2 x minus 3 squared. We're going to multiply both sides by 2 to get rid of the negative 1/2. That would leave us with 8 is equal to x minus 3 squared. We need to do the opposite of a square, which is a square root. Now, just in case you're not too familiar with it, square root of 8 is the same thing as square root of 4 times 2. That would leave you with 2 square root of 2. Now, remember, when we bring that number to the outside, this turns into a positive or negative square root of 2. So we have our positive negative 2 square root of 2 is equal to x minus 3. We go ahead and add 3 to both sides. We have 3 plus or minus 2 square root of 2 is equal to x. And that would be our x-intercept. Now it could be written like that, or you can separate them out as 3 plus 2 square root of 2, comma 0, 3 minus 2 square root of 2, comma 0. This right here would be your answer for the x and y intercepts. In slide 11, we start taking a look at an intercept form. Here we have f of x is equal to a times x minus p times x minus q. In order to find our vertex and our axis of symmetry, we need to be able to realize that we may have to work in a different order than constant vertex to axis of symmetry. In this case, our easiest route would be if we actually figured out the axis of symmetry first, then plugged it into our equation to then figure out what it would be once it was plugged in. So we're going to go ahead and prepare a quick example of this problem. So we go ahead and say that this is going to be x minus p. So x minus 5. And this would be x plus 3. Now keep in mind, when we do this, we need to figure out a number that would cancel that off. In this case, that would leave us with a negative 3 for the right side for Q, and a positive 5 on the left side for RP. When we have those numbers, that is going to give us and be able to put it into our axis of symmetry equation, which is P plus Q divided by 2. So we have 5 plus negative 3 divided by 2 is going to leave us with 2 divided by 2, which is equal to 1. So our axis of symmetry is 1. Keep in mind, that is describing our x of our vertex. So if we know that our vertex is x equaling 1, we need to find y. In order for you to do that, you need to go ahead and plug in the answer that was received, basically our x, into our equation. So as we plug in, and keep in mind, a, we just use a single variable of, or a single number of 1. We did not put anything in there. We would go ahead and plug it back in. So we have parentheses, 1 minus 5 times 1 plus 3. 1 minus 5 is a negative 4 times 4, which leaves us with a negative 16. And that would be our vertex. In slide 12, we go ahead and take a look at the exact same thing that we did. The only difference is we are now having a better understanding of what's going on graphically on our intercept form equation. So, what does that mean? That means that when we're taking a look at our graph and we're looking at intercepts, our intercepts are basically saying, hey, this is one point, this is our other point. What we're doing to find the vertex is we are adding the two together, P plus Q, and we're dividing by 2. That's going to give us our middle spot. From there, we plug it back in, which is going to give us our y. So either how high up or down. And that's how we would be able to figure out that our vertex would be down here. Let's go ahead and take a look at slide 13. So let's go ahead and start off with our parent function. In this case, y is equal to x squared. Now, because we're not able to easily see the transformations that are basically occurring off this form, I generally suggest that we go ahead and hold off on doing the transformations until a little bit later. What we can figure out much easier would be if we're dealing with a maximum or a minimum. In this case, because we are dealing with a positive a, we know that this is going to be a minimum. Now, another thing that we can easily figure out is our x-intercepts, because remember, these two portions right here, the x minus 3 and x minus 1, are both x-intercepts. Remember, we would set each one of them equal to 0 and solve for it. So in this case, we know that our first intercept would be 3, 0. Our next one would be 1, 0. So we go ahead, we can plot those out. 3, 0, 1, 0. Now, graphically, we already see that the distance between 1 and 3 is 2. 2 divided by 2 is going to give us 1. We can also go ahead and just say 3 plus 1 divided by 2, which is equal to 4 divided by 2, which is equal to 2. We plug it back into our equation. When we plug it back into our equation, 2 minus 3 is going to leave us with negative 1. 2 minus 1 is going to leave us with 1. So we have 2 times 1, which is 2, times negative 1, which is negative 2. And that will give us our vertex, which is 2, negative 2. Now we have also our axis of symmetry. X is equal to 2. Now we still need to figure out our y-intercept. We'll hold off on that until we have everything else answered. We go ahead. Notice it is decreasing from left to right, then it increases from left to right. So increasing would be from 2 to infinity, and decreasing would be from negative infinity to 2. Our domain would be from negative infinity to positive infinity. That does not change. Our range would be from negative 2 to positive infinity. And behavior, as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x would approach positive infinity. We're going to go ahead and figure out exactly where our y-intercept is going to be. Now keep in mind, y-intercept is whenever x is equal to 0. So we have 2 times 0 minus 3 times 0 minus 1. 2 times negative 3 times negative 1. 2 times 3, which is equal to 6. Our y-intercept is going to be 0, 6. So we did draw this roughly off. But our points are still accurate. So that's going to give us a little bit of assistance on narrowing down exactly how to draw this. We go ahead. Now, how do we draw our transformations based off of this? On the A side of things, we see that we have a 2. This is going to be a vertical stretch by a factor of 2. Our H and K, keep in mind, our H is left and right, our K is up and down. Remember, our vertex will always be at 0, 0 with a parent function, which means if we take a look at how much we move left and right based off of our vertex, that is going to tell us our shift left, right, up, down for our transformations. In this case, there will be a shift right by 2 units and shift down by 2 units. I would suggest try to do slide 14 on your own before reviewing the video, just to see if you did it accurately or not, and then kind of go from there. We'll run through these relatively quickly, just so that you're able to see everything. Parent function is y is equal to x squared. We go ahead, write down our x-intercepts, which would be -1, 0, and 5, 0. From there, we can start determining what our vertex is going to be. Keep in mind, 5 plus -1 divided by 2, 4 divided by 2 is 2. We go ahead, we plug 2 back into our equation. 2 plus 1 is 3. 2 minus 5 is a -3. And we have the negative from the outside. So that's going to be -3 times -3, which is a +9. Axis of symmetry is x is equal to 0. 2, 9 would be our vertex. This would be a maximum. From here, increasing would be from -infinity up to 2, decreasing from 2 to +infinity, domain from -infinity to +infinity. Range would be from -infinity up to 9. Keep in mind, this is a bracket. And behavior, as x approaches infinity, f of x approaches -infinity. As x approaches -infinity, f of x approaches -infinity. Our y-intercept is whenever x is equal to 0. So we go ahead, 0 plus 1 is 1. 0 minus 5 is -5. -1 times -5 is a +5. So our y-intercept is going to be 0, 5. Now keep in mind, even though we're only having one point here, we can actually reflect it in order for us to be able to have a very smooth parabola on both sides. Notice the distance from the y-intercept to our axis of symmetry is 2, which means from the axis of symmetry to the right side, we would be able to go 2, which would be at this spot right here. Go ahead, connect the dots. And we go ahead and take a look at our transformations. This would be a horizontal reflection of the x-axis, a shift right, by 2 units, and a shift up by 9 units. So let's take a look at that last slide. So from here, keep in mind, this would be done the exact same way. Although it looks slightly different, just keep in mind, this parentheses for the x, just around the x, would be similar to x minus 0, x minus 4. Our a would be negative, so we could just say -1 is equal to y. If this makes it easier, go ahead and rewrite it in that way so that it makes your life a tiny bit easier. We first start off with max and min. Notice we have a negative in front, so this is going to be a maximum. Our x-intercepts are 0, 0, and 4, 0. Now, in this case, it kind of works out that our y-intercept is also going to be 0, 0, because it's also running across that y-axis. We go ahead and figure out our vertex. So we've got 0, plus 4, divided by 2. 4 divided by 2 is 2. So we know that 2 is part of our vertex, and our axis of symmetry is equal to 2. We plug 2 back in. In this case, we have -2 times 2 minus 4. So -2 times -2, which is 4. From there we can see it opens downward. It increases from -infinity to 2. It decreases from 2 to +infinity. Our domain would be from -infinity to +infinity, as always. Our range would be from -infinity up to 4. Put a bracket around the 4. Our parent function, which we kind of forgot about, y is equal to x squared. End behavior is x approaches infinity, f of x approaches -infinity. As x approaches -infinity, f of x approaches -infinity. We go ahead and take a look at our transformation. In this case, we have a horizontal reflection of the x-axis. We have a shift right by 2 units and a shift up by 4 units. Hopefully this answers any questions that you might have on any one of the questions. If not, feel free to ask at any point.